Today the topic is H parameter and how we draw the equivalent common emitter configuration, how we draw the equivalent diagram of common emitter using the H parameters. Okay.
दिखी न काबे में वाइज तुम्हें झलक उसकी, दिखी न काबे में वाइज तुम्हें झलक उसकी, हमें तो बुद्ध में भी है जलवाए खुदा दिखता जो खुद
This is the two H parameter equations. This is for common emitter. Emitter is grounded and input is the base. Input is given to base, and by a sign convention we put it here a positive negative sign. This is just a convention, not the actual. And IB shown always the inward current, and collector current is again the inward by a convention, and this is a collector voltage at here. So there are four variables: VB, IB, VC and IC. By conventions all the signs are chosen. Okay, this is a conventional diagram. Now how we draw the equivalent diagram? The first equation, see VB. VB is the voltage, and that voltage is the sum of the two voltages. HIE IB is also voltage, HRE VC is also the voltage. The first voltage is HIE is the impedance. When current passes through impedance becomes the voltage, first voltage. Second is the voltage source, HRE VC. This is the voltage source. This is because of the output. From output, because here HR is the reverse voltage ratio into VC. This voltage source is the origin, is the output. Okay, and VB becomes the sum of two. First equation is complete. VB is HIE IB, the first part, and the second part HRE VC. So we completed this equation, and now this second equation is the current. That means if it is a IC is made up of two currents, HFE IB plus HOE VC. They are the two currents. The two currents separated into the parallel path. So here it is a VC. From VC it becomes IC. So IC, it is separated into two parts. You know, HO is admittance, and 1 upon admittance becomes the resistance. This resistance, when admittance multiplied by VC, becomes the current, first current, and second current is the current source, which is HFE IB. This is the current source, and its origin is the input, because IB is the base current which is input, and the emitter is grounded. The second part is completed. That's the current equation. So this is the current equation. This is the first part of the current equation is here, current source. This is the second part of the current equation which is at here. So this is the first equation. This is the first part of this equation at here, and second part it is voltage at here. VB is again a voltage. So this is how we draw the equivalent diagram. This is a emitter, this is a base, and this one is the collector. Okay, this is very simple. Thank you. Today's topic is H parameters for common emitter configurations. and to find the input resistance, output resistance, current gain and voltage gain. Okay. In two-port network, we are having the four variables. We make two variables independent and two dependent. It is our choice. In two-port network, V1 and I1 are input parameters and V2, I2 output parameters. It is our sign convention, plus, minus and involved currents. And we are making I1 and V2 as independent and V1 and I2 are dependent. So let's see 1 1 1 2 2 1 2 2 and attach H with them. So attach I1 here, I1 here, V2 here, V2 here. Remember, V2 and I1 are independent variables and V1, I2 are dependent. These are the two equations, H equations, and we are going to modify them according to common emitter configuration. In common emitter configuration, input voltage is VB, input current is IB, output voltage is VC, output current is IC. Okay, let we modify the equations with common emitter configurations. The input current I1 changed with IB, output voltage V2 as VC, and would put it here E. Okay, and V1 as VB, as well as I2 is not changed here, but it is no doubt IC. And what HI is called? Input impedance. You know why? Because it is ratio of VB upon IB. Okay, VB upon IB is input impedance, and it has happened when VC equals to 0, mean output shorted. HRE is the reverse voltage ratio because input voltage over output voltage. HFE is the forward current ratio because IC over IB. This is good. Current gain actually it is, and it is again when the output is shorted, you know. HOE is what? IC is the reverse of resistance, that's admittance. Admittance means 1 over resistance. So we are coming to first parameter, input impedance, how we find it from the H parameter equations. So again, this is a common emitter configuration, and input voltage is VB, input current is IB. So what is the input impedance? Very simple. Zin. Zin is equals to VB upon IB.
खुद पे टिकी थी तो और क्या दिखता, निगाह खुद पे टिकी थी तो और क्या दिखता, जो खुद नुमा था उसे किस लिए खुदा दिखता, निगाह खुद पे टिकी थी.
Z input impedance becomes equals to this. Now we are using the second equation for IC. Again written the IC equation. You know the collector voltage also returns by Ohm's law. Collect output current into the load resistance. Why negative sign is used? Because the load current is opposite to the direction of the conventional current, which is shown by convention. So that's why we put a negative sign. And from here we find IC minus VC over RL, and substituting there, substituting here, so it becomes minus VC over RL VC is taken common. From here we find VC over IB. From finding here from VC over IB, substituting in equation number 3. Okay, then we get the value of input impedance. So substituting it here and finding the input impedance.
तलब खुदा से सदा थी, तलब खुदा की न थी, तलब खुदा.
This is an exact equation, and if we make an approximation that HRE is small and RL is also very small, then the second term is neglected. Then the approximate formula of Z impedance becomes Z input is equals to HIE. So this is the exact equation. Approximate is Z in is HIE. This is the exact equation. Now we find the second parameter. Second parameter means current gain. Current gain is equals to IC over IB. We find IC over IB from equation 2. IC over IB, as well as we know VC equals to minus ICRL. Substituting it there,
दिखता निगाह खुद पे टिकी थी, तो और क्या दिखता जो खुद नुमा था.
from here IC is taken as common.
खुद पे टिकी थी, तो और क्या दिखता.
So IC over IB is the current gain, you know.
पे टिकी थी, तो और क्या.
You can make the approximation also. That HOERL is less than 1, then current gain becomes only HFE. This is approximate. And exact formula is, which you know well, HFE upon 1 plus HOE into RL. Okay, fine. This is a true relation. Now we will find the voltage gain. voltage gain is output voltage over the input voltage. In common emitter, collector voltage over the base voltage in common emitter configuration. We already know Vp is equals to base voltage input impedance into Ib. Then gain becomes Z, Vc over Z into Ib. Now we know the collector voltage develops across RL when passes IC. So calculating IC and substituting in equation 2, the equation becomes this. And from this equation we find Vc over Ib. Substituting this value of Vc over Ib in this equation for calculating voltage gain becomes equals to so this is the exact value of the voltage gain. Now we find output impedance. This is the equivalent circuit of H parameter. So for finding the output impedance, input voltage is the input terminal are shorted and the load resistance is replaced by the collector voltage source. Load resistor is replaced by a source of collector voltage. So RL is replaced by Vc. So input, the first equation becomes as Vb equals to 0. So first equation modifies like this. Solving this equation, simplifying, finding Ib from here. Substituting Ib here and second equation. Now from here we find the value of IC over Vc. IC over Vc is admittance. We find the impedance. We take the reciprocal of it then. So taking reciprocal of this, Vc over IC becomes, Vc over IC is the output impedance. So Vc over IC is equals to 1 upon the whole parameter, this parameter, HOE minus HFE HRE upon HIE. So this is the last output impedance. Okay, thank you very much. Now we will find the voltage gain.